When you think about a cylinder, you usually think of something that looks like this, like a can of soup, right? We call this a right circular cylinder. But we can generalize the concept of a cylinder by thinking about any curve. So in this case, we have a curve that's defined by a circle. So if we had that, and then we drew the plane that contained that circle, and then we thought about all the lines that are normal to that plane, so all the ones that come out of the plane, but specifically we constrained ourselves only to the ones that touch this curve. Then we could form a cylinder. So cylinders in three-dimensional space extend all the way out to infinity. So even though I'm drawing the top here, those lines continue forever. And so the idea what we want to talk about is something called a generating curve. And so that's the curve of interest. And then we can make a plane that contains that curve, and then we can draw all the lines through it. And that plane doesn't have to be, in the standard XY plane. It could be some arbitrary plane, right? If you had some curve that was flowing through space, as long as you can place that on a plane, you can project lines through it and you can draw the cylinder. So to do kind of an example here, let's sketch z equals sine of x. So notice we don't have a y in this case. But this would be similar to if we were doing y equals sine of x. We would draw that. That's a standard 2D thing. We're very familiar with plotting that. So, you recall the graph of the sine function. And that's not perfect, but you get the idea. I'm graphing z as a function of sine of x, or z as a function of x generated by the sine. So we need to find the plane that contains this. Well, in this particular case, since there is no y, then all the values are functions of, or z and x are the only things involved. So that's in the xz plane. So to graph that, I would just to kind of give perspective, right? That's my plane that contains the curve. And then I want to think about those normals, right? We want to think about those normals that come out of the plane. And we want to think about only those normals that come out of the plane that come through, or that also touch the curve. So since they'll all be parallel to the y-axis, probably the easiest way is to draw parallel lines to the y-axis. And so this may be hard to visualize, but the idea is that it's almost like it's going to extend. So similar to how this is just a circle sort of stacked on top of each other, you can think of this cylinder here being, it's almost like if it was in a plane and you grabbed it and you just extend it, you pulled it out of the plane. I'll pull this out of the plane and stretch it into a sheet. That's the idea of a three-dimensional cylinder.